All right, 6.1, representing relations. So back in grade 9, we learned about relations and how they could be represented, maybe like in a pedigree chart, or you could use Punnett squares to figure out genetic relationships between parents and offspring.
Oh, tips.
What?
Wrong kind of relations.
Oh.
Yeah, we're talking about relations and graphs. It's a math one.
Oh, the relations that have sets.
Yeah. So like when you think of the word set as a noun, of course, what words and ideas come to mind?
Well, I immediately think of the math version of set, but I think of things like a group or like a collection. I mean, there could be sets that just include like a single pair. But those are kind of the main words I think about. What about you? What are words that you think?
I think of like a grouping collection too, like a set of trophies from all my badminton wins.
So the set of one?
There might be a second one, I'm not sure actually.
Ooh.
Let's just put down your word pair then, because I have two.
All right, so let's talk about some of the definitions that are involved when we're talking about relations and graphs. Specifically, let's kick things off with set. So, a set, I just erased the mouth that it popped up. A set is defined as a collection of well-defined and distinct objects. So distinct meaning that each of those objects are different. The next definition is an element, particularly an element of a set. And an element of that set refers to a single object or a member of that. So if I have the set of digits, those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 is an element of that set of digits. It is one of the objects within that set. The last one we have here is relation. It is a rule or statement that links elements of one set to elements of another. The set need not necessarily be distinct. So we're going to move on right away, but if you need a couple more moments to write down these definitions, please pause the video and we will continue.
When you start thinking of these things, you can connect them to your real world experiences with the words themselves. For example, when I think of sets, I did mention like a trophy collection. I don't really have a badminton trophy collection, but anything that you have a collection of, that you can think of as a set, and then any one item in that collection, like this particular rock, or this particular Lego build, or this particular video game, would be an element of that set. And we're going to be representing relations, and as we do so, we'll see a bunch of ways to do it. We're going to be seeing tables, arrow diagrams, and sets of ordered pairs. So a table is a listing of all the links between two sets. Maybe you've seen a table of values before. An arrow diagram is where we'll have ovals to contain sets, and then we'll have arrows to indicate how they connect, to go from one to the other. And we'll also see sets of ordered pairs, and it's another way to list the rows of the table one at a time. So what's one connection, then the next connection, then the next connection after that.
So what we're going to do is we're going to start off with an example. And we're going to start off with representing two different sets. Fruits or types of fruits is going to be one set, and colors is going to be a second set. And we're going to see how those two sets relate to each other.
When we do these examples, we are going to be picking up ideas and options just kind of from tops of our heads, but a lot of these are based on what was done in previous years and student suggestions for, in this example, fruits and colors. These aren't necessarily the only options to put for these answers, but they are some of them.
All right, so we're going to do this in table form. And then it says we're going to do it in arrow diagram. Then we're going to do it as a set of ordered pairs. So just to make them incredibly clear, I'm going to just label that this is table form that I'm doing first. So when I do table form, I'm going to draw a table because I'm relating two sets together. I'm going to have two columns. And I'm going to relate fruits to colors, the set of fruits to the set of colors. And I'm just going to pick some random fruits, probably my faves, which first would be banana, because if any of you know me, My first name is Alana, and so Alana and banana rhyme nicely. So bananas, they are yellow in color. We could also say that bananas are green in color, depending what kind of bananas you like. We could say bananas are brown.
There are actually blue bananas that exist. It's a different kind of banana, but it's really neat. Yeah,
Huh.
I can't remember what the name is.
So just for the sake of argument, let's also put banana and we'll put green there. Because it is possible for banana to have two different colors. Okay. Another one, I also like apples. Big fan. Personally, I like Granny Smith, so I'm going to stick with green here. Pineapple. It's another one of my top 3 fruits, and that would be yellow in color. Let's pick up something that's not yellow or green. I don't know, let's go grapes. I know grapes can be green, so... here I'm going to say grapes are purple, just so that we get a different color.
The word purple reminds me of blueberries.
Ah, yes. Why don't we add blueberries? Although blueberries, I find, are more blue. The insides are more purple.
Yeah, I guess it's fair.
So I'm going to indicate it as blue. Because this question just said to list some fruit and their colors, as long as you can tell me that you've seen a fruit of that specific color, I am A-okay with this. We've just come up with examples here. This is one representation of how to represent the relation between the set of fruits and the set of colors. This is it. We've made a table. We call it a day. We're pretty content with our work. The next way that we're going to take a look at is how to represent the data that we collected in this table in an arrow diagram.
And when you make an arrow diagram, you can actually kind of base it off of the table form here. We are going to have 2 ovals here. One of these ovals will contain all of the fruits.
And notice that when we were talking about what a set was defined as, a set is talking about a collection of defined and distinct objects.
And the other set will contain all... What did I just do? Did I just erase that?
Yeah.
How did that happen, though? I pressed undo and it didn't disappear. Anyways. And the others, all the colors. So when we put these in, we could kind of just take all the stuff here and throw it in there. But as Miss T just said, it does have to be specifically distinct. So we can't have these multiple entries for bananas. It should only be in there once. So there's our set of all the fruits we're using. Each one is different from all the others. Oopsie daisies. That's fine. I'm leaving it at that. Similarly, for the colors, we could kind of just take all these colors here and throw them into this bubble right there. But there are some duplicates. Like we shouldn't have green in there twice, and we shouldn't have yellow in there twice. So everything that exists as part of that set is distinct. It is different from the others. I do need to reorient my fruits here because I need to draw some arrows. Whoop. Nailed it. When we finish off this diagram, there are a bunch of arrows that are going to have to be present. One of those arrows is a definition of how to connect these sets. And the rule for this one is that a fruit has a particular color. And our links are formed by whatever we see in the table here. So banana yellow means there's a connection from banana to yellow. Banana green means there's a connection from banana to green. Apple green means there's a connection from apple to green. Pineapple yellow gives us, start throwing in other colors so we can see these lines distinctly. Gives us a link from pineapple to yellow. Grapes purple gives us a link from grapes to purple. And blueberries blue gets us a link from blueberries to blue. So every single line in here has its own arrow over here. And the amount of arrows we have in this arrow diagram is the same as the amount of rows we have in table form.
Something that I always get questions about is how do we know what kind of words to put on top of the arrow? So you're just using some sort of grammatically decent structure. You do not have to have has a particular as the exact words that you use to define that relation. But anything that you can use to kind of express how fruit and colors relate and how those arrows make that relation clear. Okay, so if you're not using this word for word, that's not the end of the world, as long as you're saying something along the same lines. The last way for us to represent our relation between these two sets would be as a set of ordered pairs. And you might remember that you can write x comma y as an ordered pair. You might have seen that when you were plotting points on a graph. Well, in the same sense, we can kind of indicate points using that same type of notation. So I'm just going to write ordered pairs here so that we can distinguish the different types of relation, expressing that relation in different ways from each other. So what we're going to do is when we kick things off, ordered pairs are written in set notation, which means we have to start with these curly brackets. They're actually called braces. In math, sometimes we're a little bit lazy, but really more just so efficient that we use different symbols to represent different words. So these kind of squiggly brackets that I'll put one at the end of our ordered pairs here represents the word the set of. Okay, and so we're creating a set of, and we have to say what's in that set. Well, I would write every single row of my table as an individual set of like ordered pairs, or an individual ordered pair itself. So banana would come first, and then comma, yellow. Similar to what we would have seen before as like x comma y. But now in this case, our first set takes the place of that x value. Our second element in the second set takes the place of that y value. And we're going to do that for every single row. So we'll have banana green. We'll have apple green. We will have pineapple yellow. We will have grapes purple. And we will have blueberries blue. We also have to end our set of ordered pairs with that curly brackets to indicate that the set has ended. Couple of things that are super important. All of the elements that you've indicated first should be elements of your first set. And all of the elements that you've indicated second should be elements of your second set. The order is important. That's why they're called ordered pairs. Other things that are important when you're doing this is that we need to have commas between the two elements, right? Because if we end up comparing maybe sets of numbers, having something like 1, 2 is different than having 12 in brackets, right? So to distinguish that, we always need to separate those two elements with a comma. So those are the kind of three things: the ordered of our ordered pairs, a comma in between them, and these set notation braces.
Our next example has a more specifically defined one, so our table is already given to us here. We're going to do a few things. We're going to describe the relation in words. So how do we get from this column to this other column? And then we'll represent it as an arrow diagram, and we'll list 4 ordered pairs belonging to that relation, whichever 4 ordered pairs we want to put in there. In wordsy words, somehow we have this list of shots, and it's connected to this list of sports. So what's the connection? What's the connection between serve and volleyball, or between drop shot and tennis? We can say that in words, that the shot is used in a particular sport.
We could also represent this as an arrow diagram. Arrow diagram. So we are going to have an oval. Ooh, that's probably a little bit small. Oval to indicate our first set and an oval to indicate our second set. Our first set here is shots and the second set is sports. We have to show that arrow definition to connect the two together, and we could actually use the same phrasing that we did in our words, right? We could say a shot is used in a particular sport. Beauty. Now, we have to make sure that in each of these ovals, we only indicate the type of shot once and the type of sport once. So if I'm looking down the list, I have serve, I have block, I have drop shot, I have dump, I have spike, and I have a smash. I do the same thing for sport, writing each sport only once. So I have volleyball, quite a few times here, volleyball. I have badminton. Whoop, whoop. And I have, tennis. That's an M. Tennis. All right, so I've included all of the different elements in each of my set, and the ones that repeated, I still only included once. Now, what's left for me to do is to draw an arrow between the element of my first set to the corresponding element in the second set based on the rows of the table. So I have serve linked to volleyball, I have serve linked to badminton, and I have serve linked to tennis. I have blocks linked to badminton. Ooh, that line wasn't long enough. And block linked to volleyball. I have drop shot linked to tennis. I have a drop shot linked to badminton. I have a dump linked to volleyball and one linked to badminton. I have a spike linked to volleyball, and I have a smash linked to tennis and a smash linked to badminton. Woo!
Man, badminton's awesome, eh?
There are a lot of lines going on or a lot of arrows going on. One thing to kind of keep in mind is to make sure that your lines are relatively straight. They're not all linky and curly-do. And it helps when you space out the items in your ovals as much as possible, just to provide a little bit of clarity.
Last part of this was to provide some ordered pairs. There's many rows here. We're just asked to provide 4, just because it'd be a lot to write them all. So for our ordered pairs, we open up with that curly bracket. We list one of them, something like a block that's paired with badminton. And then another one, we could say block and say volleyball. Another comma to say our next one. Let's throw in a drop shot. And that's with badminton.
You could also do drop shot with tennis.
And yeah, I could do drop shot with tennis. That's 4. I'll close that bracket, and I'll also close my curly brace there.
All right, the last example that we're going to look at is this one here. We want to describe the relationship modeled. To describe that, we're going to do so in words, and then we're going to list 2 ordered pairs. So here we have an arrow diagram. We don't have necessarily all of the numbers because this arrow diagram would necessarily go on if we actually tried to do that. But just to kind of a quick reminder what natural numbers are. Natural numbers are our counting numbers that go from 1 upwards. So I'm going to say 1, 2, 3, 4, and so on. Okay. So what this relation is saying is that natural numbers themselves are spelled with a natural number of letters, right? So think of the natural number 1, right? It is spelled with how many letters? Well, 1, 2, 3. So it has a natural number of letters used to spell its name. So if I'm going to describe this relationship in words, I am going to essentially use the words used in my arrow diagram here, but just kind of help make it a little bit more grammatically correct. So a natural number can be spelled with a natural number of letters.
For ordered pairs here, Miss T's already kind of given us one, in that we know that the number 1 is spelled with 3 letters. And take a moment, see if you can think of some other ones that go in here. Here's another. 10 is spelled with 3 letters. And what's your favorite?
16.
How many letters does that take?
SIXTEEN. 7.
Nice. My favorite is 4, because it's spelled with 4. We've got way more than 2, but we could list a whole bunch here. 5 is also spelled with 4. And that'll do. That'll do just fine.
And that takes us to the end of the lesson. There is some practice work found in the textbook as per usual. But other than that, we will see and hear from you soon.
Bye. Oh, by the way, I found out what the blue bananas were. They're called blue Java bananas, and apparently they taste like ice cream.
What kind of ice cream, though? Banana ice cream?
Frozen ice cream? I don't know.
Interesting.
Cooked
All right.
ice cream? That's all.
Adios, muchachos.
Goodbye. What does muchachos actually mean?